Hello, my name is Chase Locks, and I'm going to be going over the basics of Houdini. The current version I'm going to be working in today is version 15.5. To begin, let's start by dropping in just a basic sphere. You can either create it by hitting the tab key, and it'll bring up this little drop down box, and you can go down to geometry and create geometry, or you can just click up, just type, let's say we wanted a cube. Oh, it doesn't have cube. Okay, tube then. Just keep hitting enter and it creates it right here at 0, 0, 0, as you can tell here. Another way you can create them is just by simply clicking and then placing them manually. That way, you get the same exact result either way. Well, me personally, I just prefer this. It's a lot faster and a lot more precise as well. Now to go over navigation, you hold down the Alt key, as you can see, and then you left mouse button, and you can rotate around your object in X, Y, and Z space. If you use Alt and middle mouse, your scroll wheel, you can zoom in and out, or you can use the right mouse button, or if you're using an Apple mouse, button 2 is your right mouse button, and button 3 is your scroll wheel. Hotkeys are pretty much interchangeable between Mac OS X and Windows. Now then, let's just scroll way the hell out on both of these. Now if you hit G, and G again, it will zoom in to whatever you have selected. Now it's selected here. You were doing this earlier. I'm not sure. Which viewport you are in, you will always zoom in to whatever object you have selected. Whether you're in your viewport here, or you're in the object tree. Let's go into the different trees. Let's go over navigation, our tools here. You have your S key here. When you hover over, it will tell you exactly what the hotkey is, which is S for this, which is your select tool. As you can see, we're selecting our object. Next one over is the T key, which is your translate. So you can translate in X, Y, and Z space, or if you're Canadian, Z. Somehow we created a geo. Don't need geo. Next one is our rotate, which is your R key, like most applications. Actually, I take that back. Most applications, it's E for rotate and R is scale. But here, they're reversed. E is scale, R is rotate. If these are really confusing for you, feel free to go into the preferences and make them custom yourself. I just used this for a while, so I just got used to it. Here are your snapping tools. You have snapping to spline, snapping to the grid, which is right here. As you can see, you can also toggle it on and off like most programs. Then here you have your multi-snapping, where you can select what you want to snap it to. As you can do it, same here with point snapping. And to see points, let's drop in a, if I can actually spell that right. Alright, so an object level, let's dive in. I did that by just double clicking. You can also dive in by, let's dive up, hit E. Not E, Enter key. Not sure why I said E. Now let's drop in a mountain top. Then on top of mountain, let's put on a scatter. Then to make it active, click here, and as you can see, updated in our viewport. Just frame this up. As you can see, we have quite a few of these. Now let's increase this to, let's just do 2,000. Let's add another 0, just make it interesting. You can see it equally distanced quite a few of these. Just to show you that, and it's generating them by the density of the mesh, or you can do it count per primitive, which doesn't do anything, or by texture space. But there's going to be nothing for texture space because currently we have no texture. Now then, as you can see, we have this here. And now, let's show you. Come on. Bring up the, where is it? There it is, geometry spreadsheet. And what this is doing, it starts at point 0, which in most other cases it will start at 1, but this starts at 0, and it goes all the way down here. Just grab the bar, go all the way down. Right here, it is 1,999, and our count is 2,000, so 1,999 plus 1 is 2,000, which gives us our face total count that we have here. And this is good because it shows you the point of X, Y, and Z for each of these, and to show that they change, let's dive up here, and for translate, let's just put in a quick simple expression, $F divided by 1, 0, 10. And what that's saying is for each frame, let's zoom out, put it on the grid to help you guys visualize. For each frame that goes by, oh, I'm wrong. There you go. It didn't look right here. Now for as each frame goes by, it's moving along. As you can see, the numbers are increasing. Here, hop into geometry, watch these numbers. Well, looking at the wrong section. Well, guess it's doing it. These are just the position points on the sphere itself, so I'd have to extrude the geometry for these to change. Well, in most normal cases, as the geometry would move, it would say point X, point Y, and point Z have changed because they have moved. But for whatever reason, it's not updating. But that's how it normally works. Bring back our sphere. Okay. Now to get into renderings. As you can see, we just have a simple flat shaded sphere here. And if we have it in a scene, let's drop down a plane. Ground plane is fine. Hit the T key. Bring it down just a tad. Disable the grid. Ridiculously bright, but that's a given. Now then, in most cases a directional light or area will be more than sufficient. Let's go with area actually. Then to rotate you, it's about there, should be good. Whoop, wrong one. On our area light. Back here. Up. Then hop over to render view. And as you can see, it updated. And it gave us our little cast shadow here based on the direction where the light is harshest, and it decays as it gets farther and farther out. And you have the harsher shadow on this side, then the brighter side on this side of the sphere. And this thing is rendering in buckets, as you can see, the little cubes that are moving all over the screen space. Let's say you love this picture for you would go right here, hop down to out. Let's say you didn't already have a mantra, so you hit tab, type in mantra, enter, enter. You have your mantra here. You select your camera. You can do that by just clicking here, then going to your object level and selecting camera. We'll say we had a camera. You'd select it, hit accept. And if you like, you can override the camera resolution if you don't like it, and make it smaller if you're just doing test renders, but you like it, so you want it 1280 by 720. But if you're doing HD, then you want 1980 by 1024. And that will give you your 16:9 ratio. And then that's also your output. This is going to put it into your temp directory. So you go here. These are just by default here. So for me, I have mine set up to go to my E drive, Houdini project folder, renders, then I create custom folders for each of the different projects. For this one, let's just call this demo scene tutorial. Test render 1. Now then, let's see what that looks like. Oh, wait, first we need to actually render it. Ray tracing is good for basics, but if you have like a high scene with a lot of details that you want to capture, then you want to go with physically based rendering or PBR. Then if you got like clouds and stuff, then you want to get into the micro polygon, so that way you get that micro detail. Or if you have like a fleece or some sort of polymer that you want the details and the micro fibers to get picked up, then you want the micro poly. Otherwise, ray tracing should just be fine for the most part. And then the pixel samples, you want that to be at least 6x6 for most renders. Anything over that, and it's going to really lag up your computer. But if you're just doing a test, a 3x3 is more than enough, and your gamma you always want to be 2x2. Then these vary depending on what your renderer is and how long you want it to take and how much detail you actually need, because the detail sometimes it may not look the best, but sometimes the render that you make, it's not going to be in the foreground, it's going to be way in the background. Like, let's say you're working on Transformers and you have an explosion going on, and that explosion is 4 buildings in the background. You're not going to see all that fine detail, so you can get away with blurring it, and instead of having the pixel samples at like 15 by 15 or 25 or 30 by 30, you can probably get away with a 6 by 6 because it's not right up there. And when you're dealing with particles, your ray samples is going to crank up to about 100, and noise level is going to crank down to that, so that way you're getting all the detail. But for us right now, we want it at default. Okay. And when I was talking about buckets earlier, this is what I'm talking about, the tiling size. You can make it larger and it will render faster, but it also will slow down your computer because it's taking up more processing power. And you can also control it by working with this. Like, instead of doing it by percents, I can do it, specify exactly, because I have a 32 gig computer, so I can tell it that, and it will use all of my RAM. But we don't need that, so this is fine. But normally when you do renders, you want to do it 0.5 for half of your RAM, or if you know you aren't going to touch your computer at all, 75. Then also when you're doing renders, you want to make sure you have this up, your task manager, because it tells you the speed of it, how much of it it's being used, how many handles it's using, the thread count, processes, and what percent each of them are being run at. Because if they're getting up to 100% the whole time, you are running a chance of overheating your computer. And then you're going to have to go make a whole new computer. And you don't want that. Now then, let's hop back over to images, and we have that set. And let's just set this back down to default, so that way it renders faster. And if you have a sequence, then you can define your sequence, and if it's not letting you do it, then just delete the channel. Then you can set the frame to whatever you want, or in this here is controlling your nth frame. So let's say we put in every 24, then that means this is now going to be rendering frame 1, frame 24, frame 48, and then it's every 24 frames. It will, to make it easier, so I don't have to do a lot of math, frame 1, 25, 50, 75, 100, and then it stops at there because there's no 125. But if we did this, then it would render frame 125. Now this is saying just render the current frame that I'm on, which, as we designate right here, it's frame 33. Now then, let's hop back over to scene view so we can render this. Render mantra. This is called mantra 2. Then an mplay window should pop up, and for me it went onto my other monitor. Bring it back so you can see. This is what it is. And it rendered at 256 by 256. Not the best resolution for you guys to see, so probably want to crank that up later. But when you're done, you can go File. You want to render, and if you have multiple frames, then do Sequence. Otherwise, just do Frame As. You want to make sure you designate the file extension, and you want it to either be JPEG if there's no background. I mean, if there is a background that you placed in. Otherwise, all other times go with either a TIFF file or a PSD, EXR, or PNG, so that way you have a transparency channel an alpha channel with you. And then here is where you designate where you want this to save to. Alternatively, you can, like we designated here, then you just hit render to disk, and it will render out the frame to your hard drive, wherever you designated it to render to. Now then, let's delete these two and just do one more simple little thing for you. Why is there an autodop? We did not get into that. The last thing that we should touch on are files. Let's say not a shopnet. That's, if I could actually type sphere, and the sphere will connect into a file. Dive into here, got our file, but we need it to be able to go out, so we want a file cache. You can get rid of that. This one, just need to tell it where you want to save it to. Then you just tile this where you want it to. Let's just, this is just going to be me off the top of my head. I think that's how Windows does it. E drive, Houdini, project, folder. I believe that's how I have it. Then it's render. After that it goes test, should be the folder, and then tile this sphere dot $OS, and that will designate your then you want it to go $, which is not $BGO, it's just $BGEO for selecting that it's an object, and then you want SC for your compression. Then when that is all done, you're good to go. Oh wait, this is not a geometry file. This is $F4. So yeah, if you're frame padding, then it's get rid of that. Fix this $F4. No, I was right. That was geo. BGEO dot SC dot SC. And that will compress your files, which if this was morphing or just animating, it would render out. And you do the same sort of thing when you when this is all good and done. this here. Your $sign save frame and simulation. And here's where you designate your frame range and your nth frame, just like we did prior. So that is the basics of Houdini. So if you have any questions, please let me know and I will answer them as soon